So error analysis is something which you might have done every now and then whenever you're doing any kind of experiment, okay? But then, sometimes we are actually missing out on the finer details. And in characterization technique or experimental technique, if you are doing any kind of characterization, any kind of study related to your samples, let's say, okay, what happens is finding out the error in the result that you have is very important. So when you are going for publishing some kind of article, okay, in some kind of reputed journal, the error part also plays a very important role. So if you're providing some kind of data and you are not saying what is the error that might be included in that particular result, this is something which is not accepted. So error is important to include, okay? And that's why this is the chapter that actually is the first unit of experimental technique, okay? So the first thing is, what is the difference between accuracy and precision? So this is something which we are going to study now, okay? So maybe I can just take accuracy first, okay? So let's talk about accuracy, okay? So I'll just give you some examples also as we go along so that it's easy for you, okay? So accuracy is how close the measured values, okay, measured value is to the actual value. So let's say you are actually doing some kind of measurement, okay? Let's say you are taking some weight, okay, and let's say the weight is 1.25 kg, okay? Let's say this is the weight that you are measuring, okay? And when you basically do an measurement by any kind of instrument, this is the actual weight, okay? So maybe I can just write down the actual weight, okay? And by using an instrument, okay, we have the values as values are, let's say, 1.23 kg, 1.24 kg, and so on, okay? So it means that your value which is being taken by the instrument is actually close to the actual value. So you can say your readings are more or less accurate, okay? And this is what is accuracy is all about, okay? And I think precision, you can guess, precision is how close the measured values are to each other. So how close the values are to each other is something which is called precision, okay? So in this above example, we can say how close are 1.24 kg, 1.5 kg, maybe, okay, kg, let's say one more, 1.26 kg. So if they are very close to each other, we basically say that this is nothing but more or less precision, okay? So in other words, we can say precision is related to resolution, okay? So I hope you understand resolution. We remember the in characterization technique that how to close two points are so that they can be easily identified is something which is called resolution, okay? So that means if 2 points are very close to each other, we can basically say that they are very precise, okay? So what I'm going to do now is probably just going to draw some figures, okay? And then from here, you are going to tell me which one is more accurate, which one is more precise, and so on, okay? So, dartboard is something you might have already seen, okay? And let me just draw three pictures here, okay? So this is one, this is, let's say, one more, okay? And let's say I'll draw one more. And then you are hitting some dirt, okay? So you are just throwing some dirts, and let's say it hits here somewhere, okay? So these are the points that we have here, okay? And let's say you are again taking the dirts and hitting somewhere here. Accuracy and precision is something which actually depends on what kind of studies you are doing, okay? So let's say these are some points here. These are hit here, okay? So you are always aiming for the bullseye, okay? So if you are going for the bullseye, basically this particular part is highly accurate. So I will just give you one example here. Okay, highly accurate, because I want to hit the bullseye and it's hitting the bullseye. So, and the points are very close to each other, so we can say they are more or less precise as well. Okay, so highly accurate, highly precise. Okay, this is the one from the first case. Okay, so can anyone tell me what is the case in the second scenario? Is it accurate? Yes or no? Is it accurate? The second part. Okay, the first part, you see the points are very near or on the bullseye, so we can say they are accurate. Okay, and they are very close to each other, so we can say they are precise. Okay, what about this case? What about this case? Can we call it accurate?
No.
Okay, what about precision? Is it precise? So let's go to the third one. Is third one precise?
Yes, sir.
Correct. So they are very close to each other, right? So they are more or less precise, but they are not accurate because they are very far from the bullseye. Okay, so we can just write down for the, let me write down the first third part first. Low accuracy, okay, high precision. So now you see, you understand the difference between accuracy and precision now, and this is something which is important. Okay, now here what happens is it depends on what perspective you are seeing. Okay, so suppose you are an archer at the Olympics. Okay, you are definitely considering this to be very low accuracy, but in general, since this is very close to the bullseye, we can just consider it to be accurate. We are not calling it as highly accurate, but we can say accurate. It's more or less near to the close value, but then low precision, because you know this is basically further from each other. These points are very far if you consider it in that scale. So you can just say accurate but low precision. Okay, so it depends on what kind of problem you are handling, and based on this you can decide. But then, you know, most of the times you'll be getting some values, some mathematical results, so it should not be very difficult to understand. This is just a pictorial representation, so it will be a bit confusing. Okay, it depends on what you consider to be accurate. Okay, if you are perfectionist, probably this is not accurate, even this is not accurate if you just want to hit this particular point. Okay, but then it is a general picture, so don't worry about this. Okay, okay, so since we are talking about error analysis, we should know what is error here. Okay, so what's error here? So basically, you know, whenever you are going to do any kind of measurement, there is going to be some kind of uncertainty involved. Okay, so that is what is error is all about. So if there is any kind of uncertainty, we basically call it to be an error. But then you need to understand this, that it's not that everything will be uncertain. For example, there is a room, and you want to count the number of people inside the room, and that's quite accurate, right? You don't have any uncertainty there. You know the number of people, you can just count, do the head count, and then you know how many persons are there. Okay, so you know everything is not uncertain, depends on what kind of measurement you are doing. So uncertainty in measurement of any uh, physical, okay, physical quantity is the measurement of any physical quantity. Okay, and maybe we can write down one point: not all measurements, not all measurements are uncertain. Okay, not all measurements are uncertain, so that's very important. Okay, like number of people in a room. Okay, so this is something which is not uncertain. Okay, even if you consider something like number of atoms in a room, that is also not uncertain. Okay, if you know the volume of the room and you use Avogadro's number and all, you can easily find out how many atoms are there in the room. So that is also not an uncertain value. Okay, so when we look into error, there are actually two kinds of errors which you actually might have already heard about. Okay, these are the systematic error and the random error. So let's just write down those points. Okay, so if we just look into errors, okay, there are two kinds of error. One is a systematic error, and then we are going to just take it one by one. Systematic error, and then we have got the random error, right? So So, if you consider something like a random error is something very difficult to control, but if you consider something like a systematic error, probably we can just have a better control on it. Okay, so this is important. So we basically have two kinds of errors here. Okay, so maybe I can just try to give it a proper arrangement so that all of you can remember this. Okay, so let's try to understand one by one. Okay, and then I think this will be easy. So we have one chapter on error analysis in class 11, but as far as my personal experience goes, many institute doesn't teach that particular chapter very well. Okay, but this is very important. You need it throughout the syllabus for physics, chemistry, maths. Okay, error is very important. So what I'm doing is I'm just trying to plan out the lecture in such a way so that even if you have missed that lecture on first chapter of class 11, you actually have a basic understanding of that. Okay, it's very important, and it's important in this the particular unit of experimental results. Okay, these error tends to shift the result in one direction. So basically it's not random, so it cannot say that all of a sudden the direction will change. It will basically have a particular direction involved. Okay, so there are a number of causes to these errors. Okay, and maybe I can just take the first cause. Okay, so there are a number of causes. The first cause is instrumental error. Okay, so instrumental error is something which you might have already observed a number of times. You take a scale, okay, and probably the scale is broken. Then what you do is you say that, okay, I will just cancel out the part which is not there. Okay, so if you are measuring from, let's say, 0 to 10 centimeter, you start from 1 centimeter. The first 1 centimeter you cancel out and you say that the total length is 9 centimeter. Okay, so that is a good example of instrumental error. Okay, so meter scale error or meter scale worn at one end. Okay, worn at one end, so that's a instrumental error. Okay, so one more is imperfection. So if you're doing any kind of experiment, be it theoretical or experimental, okay, if you're doing any kind of project work, rather, let's say, okay, in these cases it's very important that you include error as one of your result. Okay, so experimental technique procedure. Imperfection in experimental technique or procedure. Maybe I can take the example of thermometer. So when basically we place the thermometer under the armpit, okay, placed under the armpit, okay, measures the temperature, okay, lesser than the actual temperature. So if temperature is measured, your body temperature is usually measured. Usually the thermometer is kept inside your mouth, right, below your tongue. But then in general, what happens is, if we are basically taking the measurement use under the armpit, you are going to get a temperature which is less. So that is an imperfection in experimental technique. So these examples that I've taken is basically from real life. Okay, so personal error can also be considered as one example. Okay, I think again I will take the thermometer example. So if you take the thermometer and read it below the line of sight, okay, horizontal line of sight. So whenever you're going to take any kind of measurement, I'm going a bit fast because these things are very trivial. So what happens is whenever you're going to take any kind of measurement, okay, temperature measurement or any kind of device reading, you're basically going to look into the reading from a vertical point of view. Okay, just going to look into it straight. Okay, you're not going to look it from below or above the line of sight. So that's very important. So that is actually our errors. Okay, so all these three causes shifts the error in only one direction. Okay, shifts the error in one direction. So understand this, don't get confused here. Scale worn at one end, this is something which is fixed. Thermometer placed under the armpit, so every time you put it under the armpit, you are going to get a temperature which is always lower than the actual temperature. Okay, so that's in one direction. Reading the thermometer below the horizontal line, so every time if you keep on reading it below the horizontal line, you're going to get the error shifted in one direction. Okay, but on the other hand, if you're just looking into the above the horizontal line, then it's going to be something different. that's in the other direction. So that's what is meant by this. Okay, let's have some points to understand in random error. Okay, so random error is something which is irregular. I think the word defines itself. Okay, the definition: irregular, irregular errors with respect to size and sign. I think you understand this with respect to size and sign. So error might be in size. Okay, error might be in sign, if it's in the positive direction or in the negative direction. Okay, no consistent effects across the entire sample. Across the entire sample. So there is something in chemistry, we use the word isotropic. So that means it's the sample or the system is going to behave in a similar manner in all directions. Okay, but then what happens in random error, that's not the case. You might have some kind of error at some point, but at later point there might be an error which is not there. Okay, so it's basically called a random error. Okay, so maybe I can just take an example here. Okay, so basically you might have some kind of fluctuations. Okay, fluctuations in temperature, voltage. So whenever you are having any kind of voltage power supply, okay, there is a chance the voltage might be low or voltage might be high. Okay, and based on this, we're basically going to have a fluctuation. Okay, so these fluctuations are not controlled; they are random in nature. They might be more, they might be less. Okay, even with temperature, okay, of a particular system, let's say. Okay, so that is basically called a random error. Okay, so as you come across with different experimental setups, you will understand that what exactly these are there. Okay, so this is a broad description of error. Okay, so you have to keep these things in mind whenever you are going to study about these. Okay, so there is a technical problem. So just be there. Okay, just check once. Okay, and now I think it's okay. Yeah, it's okay. Okay, so we'll just go back to this, which is something which you call as the least count error. Okay, so before we go into this least count error, I think all of us should know what is the definition of least count. Okay, so any instrument can actually measure, and then which can actually measure actually will have some minimum value that it can do. Okay, so least smallest value, okay, and instrument can measure. So if you have done your experiments during your undergraduation properly, you already know what is the least error, least count. Okay, that's the minimum measure. Okay, what happens is we usually cannot measure a value smaller than this. We cannot measure a value smaller than this. Okay. That's the least count error that we call. Okay, and example might be a beta scale. Okay, and you know that you can measure up to 0.1 centimeter and not beyond that. A normal standard scale, 15 meter, 30 meter scale. Okay, so that's the least error. Okay, and if we just consider a device like, let's say, a vernier caliper, okay, vernier caliper least count error, if you want to measure, it will be basically nothing but one main scale division minus one vernier scale division. Okay, so this is something which I'm not going across. Okay, because it's important that you just revise these things you might have already studied. Okay, so if the main scale and the vernier scale does not coincide, okay, okay, main scale or vernier scale 0, I think I should write down. Yeah, the zeros of the base scale and the vernier scale does not coincide, we say that the instrument has got some kind of error, and that is actually called the least count error. Okay, so that error always needs to be connected. So we basically just find out what is the least count of the instrument and usually do our calculations. Okay, so this is something which is again important and you should revise. Okay, there are also other kinds of error. Okay, and then one of the error that I should say is the absolute error. Okay, so let me take one more absolute error. So this error chapter is going to talk a lot about errors. Okay, that's important. So let's just write down the first point here. It's the difference. So definition. So the difference between the individual measurement. So as I write, please keep on understanding what exactly do we mean this. Okay, mean by this, and true value of the quantity. So if you just find out the individual measurement, for example, the weight example that I've given, the individual measurement is 1.24, 1.23 kg, but the actual weight is 1.25. So if you take the difference between 1.24 and 1.25, which is the actual weight, you are actually going to get the absolute error. Okay, so it is denoted by delta A. Okay, so I will just it's basically an absolute value. So you whether you take the other value before the next one, okay, you're always going to have a positive result. Yeah, okay? So this is delta A. This is how it is denoted. So delta A. Okay, so this is denoted by delta A. Okay, and it means that this is always positive. Always positive. Okay, so if we just take an example here, okay, if we just take an example, you can actually measure a quantity 10 times. Okay, so measure a quantity, maybe the weight that we talked about, quantity 10 times. Okay, we'll just measure the quantity 10 times. Okay, and then if we just take out delta A1, okay, we can just say that it is nothing but A1 minus A mean. So the mean may be the actual value. Okay, and we can take that the true value, and then we can take delta A2 is equal to A2 minus A mean, okay, and so on. You can take all the 10 values. So what we are going to do is we are going to take an example and we are going to understand the different kinds of errors that we are going to discuss now. Okay, the next error that we should talk about is called the relative error. A relative error is also something which you come across again and again if you're doing any kind of calculations. Okay, so let me just write down relative error. Relative error. Relative error is important. Relative error can be represented in terms of percentage also, and that we actually call as the percentage error. Okay, so that's the third kind. But then let me just take on this ratio of mean absolute error to the, we basically take the absolute error, these errors, this is the absolute error, you take the mean of these, delta A1, delta A2, take the mean of this. Okay, so that's actually there, to the mean value, okay, of quantity measured, mean value of quantity measured. So see, I'm just writing it down as quantity because you don't know whether you're measuring a mass or volume or whatever. Okay, so it depends on what kind of quantity you're measuring. Mean value of quantity measured. Okay, so if I just write down the relation there, relative error is equal to, see, this is something which we keep on doing. Okay, but then sometimes we actually miss out what is the term exactly. So this is delta A mean divided by A mean. Okay, so what happens is these values, okay, you can just take the mean of these values. Okay, so maybe we can just take the similar example, measure 10 times, measure 10 times Okay, and then when we are measuring it 10 times, we can just take it to be delta A1. Okay, this is one value, absolute. Okay, sorry, I think this is something which is important. I should just put a absolute value here. Important. Okay, so delta A1, which is equal to A1 minus A mean. Okay, and in this way we are going to get up to delta A10, right? If you're taking 10 values, so this would be nothing but A10, the 10th value minus A mean. Okay, and now if we actually want to find out the mean absolute error, so mean absolute error, it's very simple, right? Just take it to be delta A1 plus delta A2, and then we will take all the 10 values, delta A10, right, divided by 10. So this will actually give you that value. Okay, so this is your delta A mean. And then A mean is nothing but if you take all these values, okay, A1, A2, A3, A4, and then you just take the mean of that, that will give you the A mean value. Okay, so this is what is called the relative error. Okay, and if you just want to take the percentage error, I have space. Okay, let's try percentage error. Okay, so percentage error is this. Okay, you take the relative error, you take the multiplied with 100, you get the percentage error. Okay, so it is relative error in terms of percentage. Okay, and that will actually give you the percentage error. Okay, and then how we denote it, this is actually denoted by delta A. Okay, maybe you can write down the notation here, denoted by, let's say, delta A. Okay, it depends from book to book, but then I think this is a good way to represent it. Okay, so if someone tells you a percentage error, okay, it will be nothing but delta
Sir,
A mean. Yeah,
sir,
tell me.
can you explain again from relative error?
Okay, so I'll just get back to that again. Okay, so what happens is relative error. Okay, so let's say I want to measure the weight, and let's say I have measured it 10 times. Okay, and the weight is, let's say, 1.21, 1.22, and so on. Okay, and let's say I'm measuring it up to 1.30. Okay, so these are the 10 values that I basically have. Okay, and then if I take the mean of all these values, let's say I get A mean, and this A mean is nothing but 1.25. So I have got the A mean value. That means I've got this value. So whatever are the values that I've measured, I've taken the mean of that, and that is A mean. Now I want to find out what is delta A mean. Okay, so what I will do now is I'll first find out what is delta A1, and delta A1 is nothing but absolute value. That means I can just take 1.25 before or after, doesn't matter. I can just simply take it to be 1.21 minus 1.25. So if I take this, this would be 0.04, right? So this is my delta A1. Okay, let's find out delta A2. Delta A2 would be nothing but 1.22 minus 1.25. So this would be 0.03. Okay, and then what I will do, I will keep on adding. Please remember, this is a uniform value that I've taken. So finally you might get this value to be 0 also. Okay, but then this is just an example that I'm taking. So then I will keep on doing it, and I will go up to delta A10. What is delta A10? A10 might be 1.30 plus, oh sorry, minus, sorry, this is minus 1.25. Okay, so you see, this is never going to be 0 because everything is getting added here. Okay, so don't worry about this point. 0.05, let's say. So what I'm going to do is I'm going to add this 0.04, 0.03, 0.02. Okay, and then up to 0.05. So I'm going to add all of these, and then I'm going to get delta A mean. So delta A mean would be 0.04 plus 0.03 and so on up to this 0.05 divided by 10. Okay, divided by 10. So if you take this, you are going to get the value of delta A mean. So you have got delta A mean, you have got A mean, you divide one by the other, you are going to get the value of relative error. Is it clear, Vigan?
Yeah, yes, sir. Yes, sir. It's clear.
Okay. So what happens now is that if we take delta A mean and by mean and multiply it with 100, we are going to get the percentage error. Okay, so this is actually a simple example, and based on this, let me just give you a numerical. You can take it as a homework, okay, and you can try it out, and once you complete this, I think the different kinds of error, absolute error, relative error, and percentage error, all three of them are going to be very clear, so don't worry. So maybe I can just write down this problem for you, okay. So let me just take this. So during exam, as I told, I might ask you to write chicken biryani after teaching how to prepare rice, okay. So please make sure that you understand this, okay. In successive measurements, okay, in successive measurements of period of oscillation, okay, of pendulum, okay, the readings turn out to be, so these are the values that we have. 2.63 seconds, we're just measuring the time period, okay. 2.56 seconds, so I'm not taking any kind of sequence here, I'm just taking whatever the values, let's say, we observed from an experiment. 2.42 seconds, okay, and then maybe 2.71 second, okay, and let's say the last value is 2.80 second, okay. So we basically have got 5 values here, okay. Question is, calculate the absolute errors, okay, relative errors, okay, and percentage. So you see, I have given you absolute error, relative error, percentage error. All three of them can be understood if you are able to solve this particular problem. Okay, so what I would suggest all of you is take this problem as a sum, okay, and then you try to solve this, and then if you are able to solve this, means all these three kinds of errors are more or less clear to you, okay.